All right, excellent. In this lecture, we will revise the main features of the pandas DataFrame object. To do that, we will also use a couple of examples. All right, let's start with an overview of the general characteristics. The DataFrame is the most important structure in the pandas library. There are several ways to look at it, and perhaps the most intuitive one is to consider it as a data table. It is nothing but a tabular structure that contains multiple observations for a given set of variables. That's why we define the data frame as two-dimensional. Therefore, to obtain a single data value from it, you need 2 points of reference. One is the column of interest, and the other one, the relevant row. So, as a structure, we can associate the data frame to a matrix. However, pandas users know that the data frame is just a collection of one or several series objects. Thus, whether it's representing single or multi-column data, every column from the data frame is a series object itself. This means that each column inherits the characteristics and functionalities of a series. One of these functionalities is that a series can contain data of its own type. Hence, the information in a data frame can potentially be heterogeneous, which from an analytical perspective, and given that we preserve data consistency, can be of huge advantage. The data frame structure allows you to conduct and improve your analysis in millions of ways. So, what you need is to step on some fundamentals. The rest is all about accumulating practice on working with various datasets. That said, let's focus on the following example. The data frame is a structure that corresponds to a two-dimensional NumPy array, remember? That's why we will initialize a data frame from a homogeneous array. For starters, let's import pandas and NumPy. Then, we will create a 2x3 array, which means it will contain two one-dimensional arrays with 3 elements each. We'll call it Array A. The relationship between the pandas data frame and the NumPy two-dimensional array is solid. As a consequence, creating a data frame out of Array A is straightforward. We only need to place Array A within the parentheses of the pandas data frame constructor to obtain the desired result. The type function confirms that indeed the object is a data frame. Back to the obtained output. Don't forget that when we are not explicit about the index and column names while creating a data frame, the default integer indexing will be implicitly assigned to both. Okay, as a next step, we can use the conventional name for a data frame variable, which is df, and provide the following column labels by using the columns parameter, column 1, column 2, column 3. Then, as the documentation states, we can use the index parameter to assign row 1 and row 2 as index values. See? This is how we can create a data frame from a NumPy array quickly and efficiently. Now, let's go over importing an external dataset into a pandas data frame. To achieve that, we will use the pandas readCSV method and assign loan ID as its index column. We will also store this information in a variable called data. Very importantly, we won't apply any manipulations on the data variable itself. We will be using its copy. Without going into details, we do that to avoid any concerns about the state of the original CSV file. We will call that copy lending company data. Also, we will display the first 5 rows of that dataset by using the head method. Now that we have displayed part of the lending company data, we can eyeball it. Generally, this can be considered a well-organized dataset about the loans issued by a certain company. Each loan has its ID, stored as a numeric value and a string, and has been categorized as a product of type A, B, or D, for instance. Then we have the customer gender, as well as the location and region where they live. Total price represents the total amount that must be paid for the loan eventually. In other words, this price incorporates the interest rate associated with the estimated loan risk of the given loan application. Next, start date indicates when the loan has been taken, while deposit is the sum that will be returned to you once you successfully repaid the loan. Daily rate practically shows the amount owed per day. Then, we have registered the amounts returned after 36, 60, and 360 days. Finally, loan status tells us whether the loan is active, which is the same as saying that the money is still being owed, or if the payment has been finished payment. Aside from the column names, we occasionally encounter missing data marked by NaN. The acronym stands for not a number. We don't see too many, but having some in the first 5 rows suggests that we can expect that there will be more throughout the rest of the information in the table. So, this dataset is imperfect as a whole. However, That's exactly what we need to have at hand to practice data cleaning. This will do for now. Thank you for watching.